So welcome back to the world of nucleic acids. And before we really get into the chemistry and nitty and gritty of the science portion, as far as structures and reactions go, I do want to give you a little bit of background on the history and the discovery of this nucleic acid that has become so important in today's laboratory. So we're going to first start off with this guy named Miescher. Friedrich Miescher, aka Mr. Puss. That's kind of the nickname that we refer to him as. And the reason that we call him Mr. Puss is because he loved pus. So the next time you get that infection, the next time you get that zit, the next time you cut yourself and it sets up that nasty yellow inflammation and you squeeze it out and it pops all over the mirror, I want you to think about Mr. Puss because this is what he did on a daily basis. Could you imagine? Could you imagine working with nasty pus every single day of your job? That's probably the moment where I will realize this might not be for me and I might look for another career path. But he loved it. He actually thought that he could do some good by studying this pus on a daily basis. So he is Swiss in nature. He was an organic chemist by trade, and this happened in about 1850 or 1865. So about the mid 1800s is when we see Mr. Puss come along. So what happened to Mr. Puss is that he came down with a disease and it made him go partially deaf. And he was a doctor. And because he went partially deaf, he felt like he could not really continue his job duties as a doctor for the public anymore. So he makes the decision to leave the room, leave the clinic, I guess you could say. So what he decided to do was his next best option. And the next best option was working in a lab. If he couldn't work with people and do something scientific, he wanted to at least be in the lab to do something scientific, and that's exactly what he did. So he took his organic training and he took it to the chemistry lab after he became partially deaf and left the medicinal field. And then he began to focus on these things called leukocytes. And leukocytes are basically a fancy word that means white blood cells. So as you know, you have white blood cells and you have red blood cells. Red blood cells are good because those are your oxygen carriers in a way, right? So we always take a look at your red blood cell count. And then when you come down with some kind of disease or some kind of sickness, your white blood cells start to creep up because your white blood cells are the warriors. They are the fighters. They are the ones that go out and really help order everything, not just the white blood cells, but everything in your human body to go out and start to attack this infection, this foreign substance that has entered into your body. So very often people that become sick, people that get the flu, maybe if you have a disease like HIV that begins to target your immune system, we always want to take a look at your white blood cell count. We want to know how healthy your white blood cells are, and we want to know how healthy your red blood cells are. We also want to know how much white blood cell count you have in your system, because very often high blood cell count means that your body is fighting an infection somewhere. So that's the story with red and white blood cells. We call those leukocytes. Fancy term, means something very common that you've talked about almost all the time, right? Okay, so the problem is that Mr. Puss realized that the white blood cells were very easily obtainable through infection, right? So it's going to be kind of hard for him to obtain white blood cells all the time in the laboratory. So what he begins to do is he begins to visit these clinics, he begins to visit these doctors and hospitals, you can think of them that way, and you can go and actually take these nasty bandages that they have used on these wounds and these cuts, And he gathered these pus-filled bandages all the time and brought them back to the lab. And he knew that he could extract the leukocytes from these pus-filled bandages. Kind of nasty. I told you I wouldn't want his job. Please. Could you imagine if we were trying to recruit for the program and we say, guess what, people? Your prime ideal job will be to go around and collect pus-filled bandages and extract the pus out of them on an everyday basis. I'm sure we will have a line out the door ready to sign up for the program. Okay, but that's what he did. That's what he enjoyed doing. Okay, so how did he get the leukocytes from the bandages? Well, he just basically put them in salt. That's all he did. This salt was sodium sulfate. That's what he used in the laboratory. And then what happened is that these leukocytes, or this gummy substance, yeah, kind of nasty again, just think about it. Pus-filled bandages in a solution of salt, and it starts to form a gummy substance at the bottom of the beaker that you put it in. Okay, I'm getting ready to throw up in my mouth because this is just as disgusting as pus-filled bandages are. But again, this is what he did. And then this gummy substance is what he did his testing on. And they named this gummy substance nuclein. And you can kind of see that in the middle of the PowerPoint slide here. Nuclein, nuclein. And then after a couple of tests on this gummy substance, they realized that this gummy substance was slightly acidic. So the name changes. It's no longer going to be called nuclein. What they do is that they call it nucleic acid. Just like in general chemistry, that very first class that you took from us when we learned how to name an acid, we put ic acid at the end of the name, and that's exactly what they do here. So this is how we get this term of nucleic acid. Mr. Puss was extracting nucleic acid during that time. Didn't really kind of realize it, at least the importance of it, but that is what he was extracting from these beakers. Okay, well, he eventually dies at the age of 51. So all of the studies that he began to do, he really didn't see them go to fruition, but he at least made some tread in the water, I guess, when it concerns red blood cells, white blood cells, how your body fights diseases, and this whole isolation of nuclein at the time. Nuclein, though, was not really of importance. Again, like I told you before, proteins and amino acids were thought to be genetic carrier. This nuclein stuff was just kind of on the side. Oh, that's not really important, but it's kind of neat. But because it's not important, we're not going to put a focus on it. So that's how this nucleic acid material was treated back in the day. It was shunned. Little did they know what they were shunning. Okay. Here we get another guy with the last name of Avery. I love one of Avery's quotes because he quoted underneath his name on the PowerPoint, you can see it, "It's lots of fun to blow bubbles, but it's wiser to prick them yourself before someone else does." So basically he was talking about bubbles being kind of like opportunities. You can blow all kinds of bubbles. So your life can be filled with all kinds of opportunities. And if a bubble comes around, you better pop it, meaning you better take advantage of it. Because if you don't pop it, someone else is going to be waiting in the line and they're going to pop it for you, meaning they're going to take the opportunity away from you. So Avery is one of these scientists who maybe was a little cuckoo in the lab sometimes, but he makes these general statements that kind of hold true to heart. At least this is one of the ones that I always remember. Always take advantage of the opportunity. And then if the opportunity doesn't work out in your favor, so what? I mean, I took advantage of an opportunity to go to Massachusetts. I lasted for a week, but I popped that bubble. No one else popped the bubble before I did. And it just so happens that that bubble probably shouldn't have been popped. But you know what? You don't know that until you actually do it. So we get this guy named Avery, and he was around the same kind of time period. We're still looking at the end of the 1800s, beginning of the early 1900s. He is a Canadian physician. And with this Canadian physician, he was also a specialist in the immunochemistry. So there is a whole field of chemistry that focuses on your immune system. What are the compounds? What kind of things that go on biological and chemical wise for your body to fight off diseases? Okay, so 1944, he teams up with a couple of people in the lab and he declares with this group of people, you know what, scientific community? DNA is the material which genes and chromosomes are made. Now look at the statement very carefully. DNA is the material which genes and chromosomes are made. He didn't say DNA was genetic carrier. The only thing that they attempted to say was that it makes up genes and chromosomes. Okay, now that's important for a reason. At the end of the slide, you'll see that he never received the Nobel Prize. Well, to make him feel better, we name a lunar crater after him, but we never gave him a Nobel Prize, even though that he was one of the first to actually come along and start this world of DNA and nucleic acid importance. Okay, so what did Avery do? Avery, McLeod, and McCarty all go into the laboratory and they do some kind of test. They have to do something to say that DNA is gene and chromosomes. They actually thought that it was a little bit more important, though. They had attempted to almost state that DNA is genetic carrier. But they knew if that's the statement that they made, the scientific community would laugh at them. Because again, we thought it was proteins and amino acids during the time and not nucleic acid that only had 4 molecules to make it up. Give me a break. Avery's going to not attempt to ruin his scientific career just to make a statement that everybody will begin to laugh at. So because of that, they had to downplay their discovery, at least in the beginning. So in the next video, what you're going to find out is the method that Avery uses to actually determine that DNA is a genetic carrier. We're going to talk about the studies that he does. We're going to talk about what goes on and really bring into the world of the whole research development idea, something that we've not really discussed a lot throughout the entire of the course. So we're going to take a look at what these studies really were. We're going to explain what these results meant during that time, and then we will continue on with this discovery of nuclein. Stay tuned.